In this media, you will learn about the consequences of wrong parallel connection of transformers. First, let us see what parallel connection of transformer is. In parallel connection, primary windings of two transformers are connected in parallel to a common supply, and their secondary windings are connected to a common load in parallel. Some conditions must be satisfied while connecting two or more transformers in parallel. The transformer should have the same voltage ratio, the same polarity, the same per unit impedance, and the same phase sequence and zero relative phase displacement. Next, let us see what happens when the transformers have slightly different turns ratio or voltage ratio. Voltage ratio of an ideal transformer is directly related to its turns ratio by the following equation: Vs over Vp equals Ns over Np. Consider two transformers having slight unequal voltage ratio. Under this condition also, parallel operation is still possible. Consider the voltage ratio of transformer 1 is slightly lesser than that of transformer 2. Thus, EMF produced in the secondary winding of transformer 1 is slightly high comparing to that of transformer 2. So, the resultant terminal voltage will be E sub 1 minus E sub 2, which causes a circulating current between the two secondary windings, in addition to normal load current. This leads to unequal current loading condition in the two secondary windings. Current in the secondary of transformer 1 will be more than the load current, and current in the secondary of transformer 2 will be less than the load current. Hence, the overheating of transformer 1 takes place. So, it is always preferable to parallel transformers having equal voltage ratio. Now, let us see what happens when two transformers having different per unit impedance are paralleled. Transformer impedance inherently causes internal voltage drop when the transformer is loaded. The voltage drop will be more in the transformer with higher impedance and vice versa. Hence, there will be voltage difference in the secondary outputs of the two parallel transformers. This causes the circulating current and consequent overheating, as discussed in the case of paralleling of transformers with unequal transformer ratio. However, such parallel operation can be done taking care to see that the current in either of the two transformers doesn't exceed rated load current. Next, you are going to see what happens when the transformers have different polarities. Connecting two transformers with the same polarity in parallel is similar to connecting two DC power sources in parallel with the same polarity. The secondary output voltage of both the transformers will be same, and hence there will not be any circulating current. If the transformers with wrong polarity are connected in parallel, the resultant internal voltage will be the combined voltage of the two secondaries. It will cause severe and immediate damage to both the transformers. It is a type of incorrect parallel operation. Now, you are going to see what happens if three-phase transformers with different vector groups are paralleled. Vector group means same phase sequence with zero relative phase displacement. If three-phase transformers with different vector groups are connected in parallel, there will be voltage phase difference between the two secondary windings. The resultant voltage between the secondaries will cause severe circulating current and damage to both the transformers. It is another type of incorrect parallel operation. Thus, you have learnt about the consequences of wrong parallel connection of transformers.